Section 1.2, Part 2. Here we are going to now start classifying angles. Now that we know what an angle is, we can classify it by its measure. Okay? We measure angles in degrees as of right now. There's actually two different ways of measuring angles, but we measure them in degrees with a full revolution. Meaning, if I start here and I go all the way around is 360. If all the way around is 360 degrees, there's our degree symbol. And then basically what we do is then we just divide that rotation up into 360 equal parts. Okay, so we now classify an angle based on its measure. If its measure is less than 90, this should be term, this should be the measure. The headings on these are wrong. And this one should be an example because they're angles, we don't name them. Okay, so for an acute angle, the measure has to be in between 0 and 90. Okay, a nice mathematical way of writing that, 0 less than the measure of angle A less than 90. This is saying the measure of that angle has to be in between 0 and 90. So an example of that would be an angle that looks like this. There is an acute angle. How I remember them is, isn't it so cute? That angle is small. It's small, so it's cute. A lot of times we call small things cute. It's small, so it's cute. Again, that is not a definition. This is the actual definition. It's an angle with its measure between 0 and 90 degrees. But again, I have to be in between 0 and 90. If the angle measures 0, it's not an angle. It's just straight. We'll talk about that in a minute. And if it's exactly 90, that's what we call a right angle. A right angle has the measure. The measure of angle A is 90 degrees. I didn't talk notation. This little m we put on the beginning of an angle if we're talking about the measure of the angle. Okay, so angle A, if I just use the angle symbol and talk about angle A, that's a thing. It's not a number, it's a thing. It's talking about an item like a cat. If I say the measure of angle A, it's talking about a number. How big is that angle? How much does that cat weigh? Okay, so it's the measure of that angle. So if the measure is exactly 90, we call it a right angle. Okay, so a right angle, we love to look at it. It's a horizontal and vertical rays, which again, they don't have to be horizontal or vertical. Even if it's tilted like this, it's still right. And we denote that with a little bitty box in the corner. If there is that little bitty box in the corner, we know it's right. Even if it doesn't look it, okay, we know that's right. An obtuse angle has a measure larger than 90, but less than 180. So has a measure between 90 and 180. So 90 is less than the measure of angle A, which is less than 180. So obtuse is what I like to refer to as these big angles. So obtuse is that angle that is more than 90. A straight angle has a measure equal to 180. That's straight angle, in other words, a line. Looks like that. Okay, in other words, hashtag a line. We can refer to any line as a straight angle. Any line, I could draw a line and be like, nope, that's a straight angle. Okay, because technically it is. Any line is a straight angle. Okay, now a reflex angle. Okay, the reflex angle is the angle created basically by any other angle with a measure between 180 and 360, usually. Okay, so what a reflex angle looks like. I'm going to go ahead and draw an acute angle here. Okay, so here's my acute angle. The reflex angle would be this one here. Okay, so let's say this acute angle had a measure of 40 degrees, would be this acute angle, which a lot of times we'll mark there in the inside. The reflex would have a measure of 140 degrees, sorry, 320. Because all the way around has to be 360. So I took my 360, subtracted my 40. The reflex angle is 320. So it's that big angle on the outside if I'm rotating all the way around on the outside. That's our reflex angle. Okay. All right, so now we're going to go ahead and we're going to classify some angles. So we want to classify each angle as acute, right, obtuse, or straight. And I find what's super helpful here is Post-its. Because I have so many angles going on in this picture, we need to be able to isolate which ones we're looking at. So first we're looking at angle ABG. So A to B to G. So it's going to go like this. There's A to B, and then B to G, A to B to G. That one looks acute because it's less. So, and Post-its are nice for that too, because each corner of a Post-it is a right angle. So I can like put that up to things to see, does it look right? Okay. This one is smaller. It's going in here. It's smaller than this 90, which makes it acute. Okay. That helps as well. So let's just go down the line. Now A, B, D. A to B to D's over here. So A to B to D. Well, that looks bigger than that 90, so that makes that one obtuse. Okay. Angle GBD. So angle GBD. So there's G to B over to D. That one having a little hard time telling. So again, I'm going to go ahead and put my, oh, nope, obtuse, because there's my 90. My 90 is right there. It extends farther. So that makes that one obtuse as well. So now D, B, F. Where's F? D to B to F. Oh, that's all on a straight line. So that would make that one straight. Okay, K, H, C. K, H, C. So we're looking at this guy right here. Again, these can be helpful. That one looks acute as well. Okay, D, look at all the different angles in just this picture, and we only have like 4 or 5 intersecting lines. D, B, C. So we're going from D to B to C, so it's that guy right there. Also acute. LHC. LHC. Right there. That one looks like I can stick a corner in there. Yep, I'm going to call that one a right angle. ABF. A to B to F, that little guy, acute. LHK. LHK, obtuse. And ABC is that straight. Okay. B, use a protractor to find the measure of each of the named angles. Did you classify each one correctly? So now we're going to go ahead and use a protractor. All right. There is a protractor on your template right here. This one is useful, but it's pretty tiny. But we can use it, and it's nice because you can see through it. I also have these nice big clear ones. If you didn't get one, let me know. I will get you one. Okay, the most common mistake is not knowing which set of numbers to look at. Okay, because if we're looking here, first of all, make sure it's upright, meaning make sure none of your numbers are backwards. Don't try to use it this direction. See, my numbers are all backwards. Okay. is to know which numbers you're looking at, because there's two sets of numbers. To measure an angle, you always start at the 0 and see how far this way. So if my 0 is here, I'm looking at those outside numbers. If my 0 is here, I'm looking at these inside numbers. And how do you tell? Okay, here I'm going to measure angle ABG. Okay. I start by placing my protractor and putting this little middle point on that vertex. And now there's these lines here. I have to line those up with one side of my angle. So right now I have it lined up to this side AB. So this ray BA. So that means I'm coming out here, and the 0 I'm looking at, you see it starts measuring here, 10. I'm looking at these zeros here. So that tells me I'm looking at the outside numbers. Okay. And then I need to extend this guy out and see what it's looking at. Now this is where having a ruler is also handy, because I can lay my ruler on top of here and see where it goes. So this one looks like 20. So here's 0, 10, 25. It looks like maybe 26 or 27. I'm going to go 27 degrees. Sorry, I wrote that down, 27 degrees. I was really zoomed in. So that one is acute. I was right on that one. Okay, now I also could have measured it upside down. Okay, meaning I could have lined up this ray with this one here and done it this way. But then I'm looking at, if I go out, I'm looking at this 0, which means I'm using now these inside numbers. But again, I'm going to get the same measure. Okay. And it's always a good rule of thumb. If it obviously looks acute and you get a measure of 154 degrees, then either you measured wrong or the angle is not looking right. Okay. So let's go ahead. Let's do one more. I'm going to measure an obtuse angle now. And then I'm going to have you finish these. So obtuse angle ABD. So A to B to D out here. So again, I'm going to line up my vertex and my one side. So let's scooch down a little bit. I'm going out this way here. So I'm looking at this 0. So I'm looking at these numbers on the outside. If I line this up here, I'm going to go like this, put it on the other side. It looks like, so we're at the 140, 145. We're not quite at 150. We're maybe only 1 or 2 shy. So we'll go 148. Sorry, 148 degrees. Okay, now I want you to pause the video and go ahead and fill the rest of those in. Okay, hopefully you got those all accurate. I will have the approximate answers, which you might be off by a couple, and that's totally fine. Measurement always has that level of inaccuracy. It will be when you do the practice problems. When can estimating an angle measure be useful in solving problems? Well, it's always nice to estimate if things look square or not. So if I'm estimating an angle measure, one way in which I can think of is like hanging things on a wall. I can kind of eyeball and look like it's making a 90. And our eye generally snaps to 90 degrees. We like to see things nice and square. So that's very useful in telling whether if I'm building something, does it look square? Now, estimation can only help us realize there may be a problem and we might need to measure to fix it. But that estimation is helpful in that case.